This is where we left off last class. So we're going to go ahead and start with number 9. So first off, what kind of problem is this? What kind of problem is this? There's more of them in the very back over there. Okay. What kind of problem is it? Probability. It's a probability. Great. What kind of probability is it? So there's a percentage. I went to the percentage, the 42%. So it's binomial. It's got a proportion. Can only be one or two options. That's probability. So it can't be. It's not a test or confidence interval because it's a probability. So it's not a proportion test or proportion interval. It's a proportion probability, which typically we have as binomials or even just plain straight up regular probabilities. The reason for this one is it doesn't say the probability of exactly 1 saying yes or exactly 2 or 3 saying yes. It's either all or none. So all or none are a little bit easier. We can just use regular probability for that. There's 4 students. What's the probability that you all work part-time? What's the probability he works part-time? 0.42. What's the probability she works part-time? What's the probability, not times, probability you work part-time is, what's the probability you work part-time? 0.42. So the probability that each of you works part-time is 0.42, of the probability that all of you do. So you and you and you and you and we
add?
Good question. So let's go to this one. Or's a little bit easier. So here's a dice. What's the probability that I roll a 1 on this dice? 1 out of 6. Good. What's the probability I roll a 2 on this dice? 1 out of 6. What's the probability I roll this dice and I get a 1 or a 2? 2 out of 6. So a 1 or a 2, how did you get that? Did you multiply 1 6 by 1 6 or did you add them? Add them. Ors we add. So if you're not sure which one it goes back to, one of them's multiply and one of them's add, go back to something you know and sort it out there and then apply it to the larger problem. Does that sort of make sense? The stickier stuff. So ors we add, which means that ands we multiply. Good. So here you would, so go ahead and do that. Okay, so what's the probability the first person works part-time? We said that was 0.42. Second person, 0.42. Third person, 0.42. And fourth person, 0.42. Now, you could have used binomial. If I did binomial, is it going to be PDF or CDS? CDF. And remember?
Is it PDF?
PDF. Because I want just what, I don't want cumulative. I don't want everything from 0 up to 4. I want just 4. So that's going to be PDF. And what's my n here? How many students am I picking? 4. What's my little p? 0.42. And how many do I want to say yes? 4. Either way, you'll get the same answer, which is 0.031. Is that correct?
Yeah.
1. Is this likely or unlikely? So what's our general guideline for unlikely?
Under 5%.
Yep, 5% or less. So is this unlikely or likely?
Okay.
Yep, it's unlikely because it's 5% or less. Everyone kind of follow that? Now, what's probably that none of them works part-time?
Doesn't none mean all in this case? It's all, or does it mean different?
It means all of them don't.
Yeah.
Yeah, none of them means no, 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 no. All of them say no. I probably should have written that. We had to go this one this way. This is probably a yes, 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 yes. Right? Let's see the probability of no, 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 no. I get all 4 no's. So what's probably the first person says no? Yeah.
0.58.
Yeah, 0.58. That's not the answer for the whole problem. But it's probably the first person says no. What's probably the second person says no? Third person? 0.58. Yep, and last person? Yep. So this would be first person and the second person and the third person and the fourth person, and we multiply. So 0.58 multiplied by itself 4 times. Or again, you could do binom PDF of 4, 0.42, comma. How many yeses do I want? 0. And either way, you'll get the same answer, which is 0.113. Good? Does everybody else got? Okay, great. Moving on, problem number 10. So you're all familiar with this one. Fill in the table and then answer the probability questions. Let's check in and see if folks are at. So first, do your totals. What's probably someone likes broccoli? Well, there are 51 people who like broccoli. Out of how many people? 100. So that is 51 out of 100. Man or child? Well, let's see, there are 38 men. There are 22 children. So, and earlier we said ors we add, so we're going to add them out of 100, 60 out of 100. What about child or likes broccoli? Let's see. There are 22 children, but likes broccoli, there's 51 people. Here's my problem with this one. Take a look. See these 10 people here? They're counted in the children group, but they're also counted in the broccoli group. They're getting double counted. So they're getting counted in the 22 and they're getting counted in the 51. So if I add up 22 and 51, I have to subtract off 10 because that 10 is getting counted twice. So 22 plus 51, the totals. But I have to subtract 10 because 10 of them are being counted 2 times. Yep, 63 out of 100. Next, dislikes broccoli and is a man. How many of them dislike broccoli and are men? So here are my men. 21 dislike broccoli and they're men. So that's going to be 21 out of always out of 100. Your probabilities are always out of everybody unless you're given something. Given is the only time it's not out of everybody. Because given means that you know it's a subgroup, so your denominator it's out of fewer people. Otherwise, unless it's given, it's always out of everyone. So speaking of given, the next one is likes broccoli given they're a woman. So that's what this line straight up down means. It means given they're women. So likes broccoli and they're a woman. So the people usually they get the 24 pretty easily. The question is, they aren't sure what to put on the denominator. So see this given symbol, how it's kind of straight up and down? It's very similar to the division symbol like that. So you divide by the total number of women. So how many women are there? 40. Good. And again, remember, you can always leave these as regular standard fractions. I don't need you to simplify them. They don't have to be, lowest common denominators or any of that stuff. And the last question is, are likes broccoli in women independent or dependent? What do y'all think about that?
Let's say independent because because it could be either or.
Okay, so one thing I'm going to point out is everything here is in this survey. I'm selecting someone from this survey. In this survey. So the probability that they like broccoli given their woman in this survey, not in the whole world, just in this survey. Does that make sense? Probably they dislike broccoli and they're a man in this survey, not out of everybody. So in this survey, are liking broccoli and women independent or dependent? This is similar to chapter 11. What's our test for independence the same as? Independence and homogeneity of proportions.
The matrix.
Chi-square matrix. So, in other words, if you're independent, your proportions are the same. So we need to see if the proportions are the same. So, so in other words, the probability that you like broccoli compared to the probability that you like broccoli given you're a woman. So what's the probability someone likes broccoli? 51 out of 100. Everyone see that? Okay. What if you're a woman? What's the probability you like broccoli? 24 out of 40. So what you do is you find, see how those four things make a rectangle? You find the first one, women who like broccoli, and then you find all the other things that have to do with women and broccoli. So women and broccoli, total women, total broccoli, grand total. It's just like the chi-squared. You have your value, women who like broccoli, and you have your row total, your column total, and your grand total. And those proportions need to be the same. That's where the expected values come from, actually, is from this proportion solving back for the women and broccoli, for example. So the question becomes then, is 24 over 40, I'm going to compare that, is that equal or not equal to 51 over 100?
Not equal.
Not equal. So if they're not equal, they are
Independent.
dependent.
Oh, dependent.
Remember, test for independence is the same as proportions being equal. If they're equal, they're independent. You can think about it this way. If I'm independent, then I'm equal. Kind of like if a country fights, like the United States, they fought for their independence from England so that they could be equal with England instead of being a subject of England. Right? If you're independent, then you're equal. All right. 11 we did last class, so I'll patch in that video into this spot here.